Good day everyone, I am Yolin Aurea and today I am going to discuss to you the different theories on the origin of life. But before that, let's watch this video first. In our vast universe of an imaginable size and age, within a spiral galaxy billions of years old, among an immersed nursery of stars, rich in the elements of creation, our star was born. From the forge of its infant solar system, at just the right distance from the sun, a new planet was born. A place called Earth. It was a hot, violent world, barren and lifeless. It was a world of water and fire, toxic gases and smoke. But something magical happened to Earth to change all of that. Life. Life on Earth begin? How did we get from this to this? Was life born as a random combination of atoms? Did life come to Earth from space long ago? Or was the Earth and its life created by gods? Let's explore the origin of life. So now, let me ask you a question first. In your own opinion, how many theories does the origin of life have? Very good. So, we have 7 theories on the origin of life. And the first theory says that it started with an electric spark. Electric sparks can generate amino acids and sugars from an atmosphere loaded with water, methane, ammonia, and hydrogen, as was shown in the famous Miller-Urey experiment reported in 1953, suggesting that lightning might have helped create the key building blocks of life on Earth in its early days. On the other hand, over millions of years, larger and more complex molecules could form. And now let's watch this video.
Electric spark or primordial soup. This theory suggests that the first biomolecules may have formed during lightning. There are 2 distinct versions of the spark of life theory. The first of these versions holds that the first form of life came into existence following one spark or on one particular spark day. Another version holds that the first life on Earth may have been caused by million years of continuous lightning. If we learn about the Miller-Urey experiment, this theory will be more easier to understand. In 1953, 2 researchers, Miller and Urey, embarked on effort to create life molecules by electric spark. They assembled an atmosphere which was similar to the atmosphere of the Earth. It consisted of gases like ammonia, methane, hydrogen sulfide and water, but no oxygen. They maintained the mixture of these gases at a temperature of slightly less than 100 degrees Celsius, and passed electric spark through them. That spark induced lightning. After the experiment, it was observed 15% of carbon from methane got converted into simple carbon components like amino acids. This amino acid is capable of forming protein. Hence, over the million years, certain conditions in the atmosphere of early Earth gave rise to complex molecules, which eventually gave a first living thing.
Although research since then has revealed the early atmosphere of Earth was actually hydrogen poor, scientists have suggested that volcanic clouds in the early atmosphere might have held methane, ammonia, and hydrogen and have been filled with lightning as well. And the second one is, the lightning may have provided the spark needed for life to begin. The first molecules of life might have met on clay, according to an idea elaborated by an organic chemist, Alexander Graham Cairns Smith, at the University of Glasgow in Scotland. These surfaces might not only have concentrated these organic compounds together, but also help organize them into patterns, much like our genes do now. The main role of DNA is to store information on how other molecules should be arranged. And now let's watch this video.
Community clay. The clay theory was introduced by organic chemist Alexander Graham Cairns Smith. This theory suggests that the first molecules for life are formed from clay. Let me explain this theory simply. Over time, the biological molecules evolved to the point where they learned how to replicate without the crystals, which is called a genetic takeover. This theory started because if you look at clay underneath a microscope, there are miniature crystals within clay. Also, when you look at each crystal, there are atoms organized that have a pattern that repeats in a tight and condensed arrangement. All the crystals can expand when water is laced together with, and they have the same chemical substances. Since the crystals can also split apart, it can create a mother crystal that can create multiple daughter crystals. All crystals aren't the same, so every crystal has its own distinctiveness, and that passes down to the daughter crystals. The cycle that clay crystals go through is very similar to the process of genetic mutation, which is the process that creates new traits in all living organisms. Organic molecules took over this job and organized themselves. All the experiments to prove this theory have failed, and this theory has been put on hold.
The third one is, life began at deep sea vents. The deep sea vent theory suggests that life may have begun at submarine hydrothermal vents spewing key hydrogen-rich molecules. Their rocky nukes could then have concentrated these molecules together and provided mineral catalysts for critical reactions. Even now, these vents, rich in chemical and thermal energy, sustain vibrant ecosystems. Let's watch this video.
Deep sea vents. This theory suggests that the first life may have been created from the depths of the ocean. Accordingly, without the help of sunlight, biomolecules were formed in the deep. Under the Earth's ocean, there are vents where seawater comes into contact with minerals comes from the Earth's crust. Hot minerals from the Earth's crust react with the vent to emit black smoke. In that place, hot gas and cold salty water mix together and create a warm, alkaline environment containing hydrogen. This process creates the mineral-rich chimneys with alkaline and acidic fluids, providing a source of energy that facilitates chemical reactions between hydrogen and carbon dioxide to form increasingly complex organic compounds. Scientists believe that it was during this event that the protocells which helped to create a cell must have formed. And they succeeded in those experiments. Also, they found the heat, alkalinity and salt did not impede the protocell formation, but actively assisted it. But a functional protocell has not yet been achieved in the laboratory. But despite the many flaws in this theory, we cannot rule it out.
And the fourth theory said that the life had a chilly start. Ice might have covered the ocean 3 billion years ago, as the sun was about a third less luminous than it is now, scientists said. This layer of ice, possibly hundreds of feet thick, might have protected fragile organic compounds in the water below from ultraviolet light and destruction from cosmic impacts.
This theory suggests that life may have evolved from ice. Ice might have covered the oceans 3 billion years ago with 100 feet, as the sun was 3 times less luminous than it is now. Researchers proposed in 1994, for example, that repeated cycles of freezing and thawing could help accelerate some of the chemical reactions necessary for life. Although life as we currently know it requires liquid water, small amounts of liquid can persist even at -60 degrees Fahrenheit. Scientists argue that microscopic pockets of water within ancient ice may have gathered simple molecules, which assemble into longer and longer chains, forming the foundation for life. They believe life began inside hundreds of feet of ice. Also, these hundreds of feet thick layers of ice might have protected fragile organic compounds in the water below from ultraviolet light and destruction from cosmic impacts. This theory therefore justifies the notion that organisms must have evolved from water to land. But it also has many flaws.
And the fifth theory said that the answer lies in understanding DNA formation. Well, the RNA can store information like DNA, serves as an enzyme like proteins, and help create both DNA and proteins. On the other hand, RNA still exists to perform several functions in organisms, including acting as an on-off switch for some genes. Some scientists think the molecule could have spontaneously arisen on Earth. Others say that was very unlikely to have happened. Other nucleic acids other than RNA have been suggested as well, such as the more esoteric DNA or DNA. And the sixth theory said that the life had simple beginnings. Well, instead of developing from complex molecules such as RNA, life might have begun with smaller molecules interacting with each other in cycles of reactions. These might have been contained in simple capsules skin to cell membranes, and other time more complex molecules that performed these reactions better than the smaller ones could have involved.
Simple beginning. This theory suggests that the first life may have formed on Earth very simply, unlike any theory seen before. That is, instead of developing from complex molecules, life might have begun with smaller molecules interacting with each other in cycles of reactions. These reactions might have changed a simple capsule to cell membranes and over time more complex molecules or cells.
The last but not the least, it was said that the life was brought here from elsewhere in space. On the seventh theory, it was said that life did not begin on Earth at all, but was brought here from elsewhere in space, a notion known as panspermia.
This theory is given that the first life on our Earth may have been caused by an asteroid. Since the day our Earth was formed, there have been thousands of asteroids hit the Earth. From one of them, life may be started. Somewhere in the universe, the rock, which split from the planet, may have been carrying the microbes. When it crashed into the Earth, that microorganisms were likely to have spread to the Earth. That is, life formation did not take place on Earth, it took place somewhere else in space or on any other planet and brought to here.
Rocks regularly get blasted off Mars by cosmic impacts, and a number of Martian meteorites have been found on Earth that some researchers have controversially suggested brought microbes over here, potentially making us all Martians originally.
It is also possible that some of the biomolecules on our Earth may have been traveling through deep space along with those rocks.
So, the following are the answer lies in understanding DNA formation, which can store information like DNA, serve as an enzyme like proteins, and help to create both DNA and proteins. These are the following. Number 1, life had simple beginnings. Second, life might begin with the smaller molecules interacting with each other in cycles of reactions. The third one is life was brought here from elsewhere in space. Fourth, it was brought here elsewhere in space. And last but not the least, life might have hitchhiked in comets from other star systems.